Hello everybody. So what I want to do today is I want to post a video for you guys helping you out with the pyramids, right? Three-dimensional solids. So I feel like some of these pyramid questions are a little tough because of the slant height and using the Pythagorean theorem. So here's what we're going to do. I'm going to start off with this example. So it says find the surface area and volume of a right regular hexagonal pyramid. So what makes it right? Well, the fact that it stands straight up, right? So if I connect the base all the way up to the apex, it stands up at a right angle. Regular, which means the base is perfect. All right, the base is a hexagon, which means it has 6 sides, so that means it's equilateral and equiangular, right? All the sides and angles are equal, it's perfect. Now, it also is a pyramid because it has one base and is connected to one point with triangles. All right, so basically here's what we're going to do. They give us some information. They say it has a base perimeter of 24 feet. So that means all 6 sides of this base add up to 24. So 24 divided by 6 is going to give us 4. So I could go around this entire figure, around the whole base, and I've taken another picture. So this is just the base. We're going to ignore everything else. So I could go around this entire base and put 4s on all of the sides. Now when we get down here, guys, I think we should recognize this by now. We're going to find the area of the base by cutting it up into triangles, excuse me. So this length here will still be 4, but it's bisected into 2, what do we got, feet? Yeah, 2 feet each. All right, now, since this is a hexagon, all right, what I want to do is review something that's going to come up again in the next video, but I want to find this whole angle here. Now, if you remember, we take 360 and divide by how many triangles there would be. So if I were to draw all 6 of these, right, I would have 1, 2, 3, 4, 5, 6 central angles. So 360 divided by 6 is 60. All right, so this whole angle is 60 degrees. Now, this triangle has 2 equal sides here as well. So that means this angle and this angle are congruent or equal. So 180 minus 60 is 120. Divided up equally gives us an equilateral triangle here. Okay, remember hexagons, this happens in hexagons only. This is a special case. All right, so I have an equilateral triangle here, and when I draw the height of it, it's now going to split that 60 degree up into 30 degrees. Ladies and gentlemen, if you look at what it says here, leave all answers in exact radical form, no decimals. So we're going to use our special right triangle rules. Okay, so if you remember, right, 30, 60, 90, if the short leg is x, then the hypotenuse is 2x, and the long leg is x radical 3. Okay, so right now, guys, we know the short leg is 2, right? We would also know that the hypotenuse is 4, and the height now of this triangle is 2 radical 3. All right, now that is really important here, okay? So I wanted to show you something here. If I were to draw, say, the other side of, let's just say I draw another triangle over here, right? Let's think about this. This is what I wanted to do. If I draw another triangle here, all right, guess what? This height here would be the same as what I just did here, all right? It would still be the 2 radical 3. So why am I making a big point out of this? Well, here's what we have to remember. This hexagon is the bottom. It's like the floor of this pyramid. So if I go back up top here, right? Yes, this is 4. Remember, this whole side is 4, but look right here. We split it up into 2 and 2, right? And this is really, really important. This is kind of hard to see. This length right here goes from the center out to the midpoint of a base edge. So that's this length here, right? Or this length here. So this is actually 2 radical 3, right? So that is the length, and we need that in a second, all right? But I'm going to come back to that later. So here's what I want to do. Let's follow a couple simple steps. Step 1, find the area of the base, okay? So here's the shape of the base. So hopefully we should remember that it's going to be 6 times the area of this triangle right here. Right? 6 times the area of this triangle right here. Okay? So what I'm going to do is I'm going to take my values and substitute them in. The base of the triangle is 4. I don't want to use half of it. I want to use the full base. So it's going to be 1/2 times 4 times the height of the triangle. which is 2 radical 3. Okay, so what I want to do first is I want to do these stuff inside the parentheses here. Half times 4 is 2. 2 times 2 is 4. So each triangle is 4 radical 3 square feet, and I'm going to multiply that 6 times to get the area of the full hexagon. So that's going to be 24 radical 3 feet squared. Okay, so that's the area of the base. Okay, now I'm using this fancy word here. It says find the apothem. We actually did. Okay, the apothem is this length right here. It's actually the height of this triangle. Okay, so that's important. The reason why it's important is, oh, I forgot to label something. Look, we have a base perimeter of 24, which we labeled, okay, but it also has a height of 10. I missed that. Let's get that in here. So let's think about this. We know the height is 10, right? We are going to need the slant height later when we're going to try to find our surface area, okay? So this is why I really wanted you to see these two kind of side by side. I'm going to draw the slant height over here. Okay, I think this is the tricky part. Okay, I'm going to draw it in green. Okay, but I hope you notice that we now have a right triangle that is inside of the pyramid, right? It's in here. It's inside the pyramid. It's hard to see. I'm trying to highlight it best I can. But what I'm going to do here is this. The slant height is right here in green. That's going to be my slant height. But on a side note, I'm going to redraw this right triangle. Okay. So I knew that the height was 10. I'm going to put that there. I now know this length. That's what we needed, is 2 radical 3. So now I'm going to use S for slant height. So for step 2, it says to find the apothem, which is this right here, and then find the slant height. Okay? So that's what we're going to try to find right now. I'm going to use the Pythagorean theorem. So I'm going to say 2 radical 3 quantity squared plus 10 squared equals S squared. Okay, now we got to remember some algebra from the year, guys, so I'm going to square both pieces in here. 2 squared is 4, and radical 3 squared is 3, okay? So then I'm going to have 4 times 3, which is 12, plus 10 squared, which is 100, equals S squared. All right, so not so pretty here, but we're going to get S squared equals 112. Excuse me. All right, take our square root. Now they've said leave it exact, so we're going to have to try and simplify this, okay? Now since I know that 112, I think 112 should be divisible by 4, so I'm going to take 112 divided by 4, and that gives me 28. Ooh, I could divide that by 4 again, which gives me 7. So wait a second. So I divided by 4 twice. Let me see if 7 times 16, yeah, 7 times 16 is 112. All right, so let's see. So that's going to give us 4 radicals, 4 radical 7 for our slant height. Okay, so I'm going to put that over here. It's a tough question. So now finally we are ready to finish up our surface area and volume. So I'm going to write my formula. Surface area equals 1/2 PS plus the area of the base. Now don't forget, guys, we did that already. Okay, but I'm also going to write down my volume formula, which is 1/3 capital BH. All right, so let's go through and substitute our values. Surface area is 1/2 the perimeter of the base. Well, they gave that to us from the very beginning. That's 24. What is our slant height? Oh, we just found out our slant height to be 4 radical 7. Plus, we want to add the area of one base, right? The one hexagonal base. We've done that already, and that's 24 radical 3. So now we're going to take our final surface area. Now, 1/2 times 24 is 6. 6 times 4 is 24. So that's going to give us 24 radical 7 plus 24 radical 3 feet squared. Guys, can we add these two together? They are not like radicals. We'll leave them separate. Finally, we get to our volume. Volume is going to be 1/3 area of the base times the height, not the slant height. Okay, I usually like to continue saying you use the slant height for the surface area. If you think of the S's, we use the true height for volume. Okay, area of the base was 24 radical 3. The height of the pyramid is 10. So here we go. 1/3 times 24 is 8. 8 times 10 is 80. So the volume would be 80 radical 3 feet what? Feet cubed. Okay? Guys, these are tougher examples here. That's why I wanted to provide you with a guide. I hope you understand. If not, just reach out, send me an email, let me know if you have any questions. Thank you.